I want to find the resultant moment of these two forces about point A. So again, what I'm going to do is I'll first break these forces up into their horizontal and vertical components. So this force F will have 4/5 horizontally times, that would be times 80. And then vertically will be 3/5 times 80. Okay, P is 50 pounds. Okay, and that's going to be basically a sine and a cosine 45. So again, if I've got 45 here, we'll call this 50 cosine 45, and this one here 50 sine of 45. Okay, so now for each one of these forces, I want to take the moment of each force and then add them together. So we'll start with the 80. So I'll say the moment of A of 80. Now, I've got a horizontal and vertical component. Notice that the vertical component goes right through point A. Therefore, the moment arm of that vertical component is 0, so it creates no moment. The only thing that creates a moment is that horizontal component of the force. Therefore, I'm going to take that vertical distance, 12, times the horizontal force, which is 4/5 times 80. And again, the 3/5 goes right through point A. So there is no horizontal distance to that vertical force. It's 0. So I only have the vertical distance times the horizontal force. Now, this force about point A is creating a negative moment. Okay, so I need to include that negative answer there because it's going clockwise about point A. So that will be a negative moment. So that becomes minus 6 or 768, excuse me. Now I'll do the same thing for P. I'll call about A of, I guess I'll call that 50, that force P there. Okay, again, that vertical component goes right through point A. There's 0 horizontal distance between the point and that force, right? So if it's 0, there's no moment due to the vertical force because there's 0 horizontal component. That force, that vertical force goes right through A. So I only concern myself with the horizontal component. So I'm going to take that vertical force, which is 18, times the horizontal force, which is 50 cosine 45. So again, I'm taking a vertical distance times a horizontal force. The horizontal distance is 0 times that vertical force. That vertical force goes right through point A, so it has 0 moment arm, so it creates 0 moment. Okay, this is going in the opposite direction about point A. It's going counterclockwise. We call that positive. So that moment then becomes plus 636 when I do that vertical distance times the horizontal component of that force. Now, the resultant force about point A is just those two added together. And when I add those together, I get negative 132. And my units on this are, again, my distance of feet and my force of pounds. So I've got foot-pounds. So take each force, find the moment of each one, then add them together to find that resultant moment.